Hey guys, this video will help you with the homework that was assigned Tuesday, Wednesday, February 3rd or February 4th, depending on which class you're in. And the assignment is 68, 95, 99.7% investigation. So before we do anything, let's just do a quick review of what the 68, 95, 99.7% rule is, and then proceed from there. So if you can remember in class, what we talked about is if you have a normal distribution, okay, on a bell curve, you have your mean right in the center, and then you could go one standard deviation in either direction from the mean by adding one standard deviation or by subtracting one standard deviation. So this region in between these 2 points, one standard deviation both directions, is where the majority of your data will usually lie. Actually, exactly 68% of your data typically falls in that first standard deviation. Within 2 standard deviations, so if we take the mean and if we add 2 standard deviations to the right and subtract 2 standard deviations, let me use a different color for this. Typically, 95% of our data will fall within this region. 95%. And then if we want to take it even farther out, there's 3 standard deviations. Typically, 99.7%, nearly all of our data, will fall within 3 standard deviations of the mean. Okay? So what does this mean? It means that the further and further we go out, the less and less data we're going to have. The more odd, the more abnormal our data is going to be. Like if you think about height, the average height of somebody is probably about 5'7" across all the world, men and women. Here, like within standard deviation, these would be like normal sized people, right? As you get beyond 1 standard deviation, you're starting to get in like, the gigantors, the 6'5" people, the people that would stand out in the crowd. Beyond 2 standard deviations, this is where you have like the really tall people. Beyond 3 standard deviations, these are like the Shaqs, the Shaquille O'Neals, the people that are 7 feet or above. These are like the really, really tall people. So hopefully that gives you a little bit of context. But most people are going to fall within this 68% within 1 standard deviation. Actually, 68% of people will fall within this 1 standard deviation. So let's move on to the homework now. What you're presented in the homework is a histogram. It looks something like that, and you have hotel rooms and you have the frequency. So this is a particular hotel, and it looks like there were 2 days where the hotel only had about 20 rooms occupied. And there's about 1 day where the hotel room had all 240, I'm guessing, rooms occupied. It's a big hotel. So the first thing you have to do is you have to simply count up all the data points. So you basically just count the numbers along the bars, right? You have 2, you have 1, you have 3, you have 1, you have 5, 4, 7, 7, and so on and so forth. So you're counting the total number of data points, in other words, that were gathered in this study. So you count up the totals for each bar. You're not concerned about the hotel rooms occupied because this is something else. This represents your actual data. You're counting up the total number of points, basically. So what percentage of the data falls within 1 standard deviation of the mean? Well, thankfully, they've provided the mean and the standard deviation for us right up here. The mean is 125. Where would that fall along our histogram? Well, if you look closely, we have 120 right here, and then the next number over is 140. So we can deduce that the line in between the 120 and the 140 is 130. So 125 would fall just to the right of 120, in between the bar right there. Okay, so that's where my mu. I'm going to label my mu on there. Okay, so our standard deviation is 44. So if we go 44 in both directions from that mean, in other words, if we add 44 to 125, we get what? We get 169. Where would 169 fall? Well, here's 160. The next line over would be 170. So 169 would fall just shy of 170. So I'm going to label that point on there. I'm going to say this is mu plus sigma, or mu plus standard deviation. Hopefully you all can see that. And if we go in the other direction, if we go our mu minus 44, or 125 minus 44, we would get 81, which would put us just after the 80, so that would be mu minus a standard deviation. Just like that, okay? So what we're doing in this assignment is we're verifying that the 68, 95, 99.7 rule is somewhat accurate, okay? So what we need to do is, after we gather our totals on number 1, we have to gather the total of data points that fall within that 1 standard deviation range. So in other words, and this is a little imprecise because the numbers don't land perfectly where the boundaries of the bars are, but this 81 point right here, this is mu minus 1 standard deviation. Notice I fall pretty close to the start of this 7 bar. So I would count the numbers in between this 7 bar and where do we end up? This 8 bar right here. The mu plus a standard deviation falls pretty close to the end of this 8 bar. So this is going to be a little imprecise, but we're going to do the best we can. So I would add 7 plus 12 plus 8 plus 9 plus 26, that's the highest bar, plus 10 plus 14 plus 10 plus 8. And I would get that total. And that total would represent, roughly, the amount of points within 1 standard deviation of the mean. Okay? And once I had that total, I could divide it by the total numbers in the whole histogram, and that would give me the percent of data that fell within 1 standard deviation of the mean. I'll just let you in on a little secret. It probably is going to be pretty close to 68%. It should be. If you get like 90% or 30%, count again. Okay, that means that you're probably not counting correctly, or something happened the first go around. Okay. After that, you're going to look at the data that falls within 2 standard deviations of the mean. So in other words, from this 169, what I counted the first time, for 1 standard deviation, I'm going to add another standard deviation. I'm going to add another 44. So what is 169 plus 44? 79, 89, 99, 209. That would be what, 213? So that would put me pretty far to the right, 213. So that would put me like right over here, 213. So kind of in the middle of the 4 bar, right? Or kind of towards the, yeah, we could say that. Probably maybe towards a little bit further to the left of the, yeah. So I would probably include this 4 bar in my calculation. And then where would we be over here on this side? Well, if I subtract another 44, that would put me at, what, 41 minus another 4, 37. So 37 would put me pretty close to 40 right here. And so I wouldn't include the 3 bar. I would include everything after the 1 bar. Okay? So we may have a little bit of variability in these calculations because it's hard to kind of eyeball and predict what you should include and what you shouldn't include, but hopefully that gives you an idea as to what to do. Okay, a little variability on this assignment is okay. I just want you guys to get your minds thinking about what this rule actually is and how we see it in actual data. So let me know if you have questions, and I'll see you guys Thursday or Friday. See ya.